We are getting close to the end of the year. Chapter 19, we're almost done. There's just chapter 20 and 21 left. But if we do chapter 19, make sure that you've actually done the terms first. Otherwise, chapter 19 might not make sense. So doing assignments in order does help. We're going to go a day at a time. So today, Thursday, we should have started slide 1. There's only 2 sections of chapter 19, but we have notes and an article slide as well. So let's go find our slides and press that arrow, the square arrow, to open that in slides. Then you can double tap so you can edit, press the book symbol, and open link with the textbook pages, and split screen back to slides, and there you are. So we already read an article about a drought experiment in this building, Biosphere 1. Biosphere 1 was not originally a science building, and so you got to read about its original purpose. And they had a good idea. I mean, this is a giant building with a rainforest in there and a ton of different biomes created in the deserts of Arizona. And they had a good idea, a good experiment to see how long people could survive in there without any help from the outside world, not even air. And you have to tell me why it failed and what Biosphere 2 is. Now, if we go here, rain is a very important part of the water cycle. Precipitation, the fancy name for rain, is how clouds, water vapor in the air, turns to liquid to fall back to Earth. And what percent falls on land? Well, they tell you 91% falls in the ocean. So you've got to do a little bit of math to back that up and figure out how much the rest is that falls on land. And then if you read the very next sentence, you'll see why that rainfall is important. If we go to question 3, water cycle has many routes for water to become liquid and vapor and back and forth. Now, evaporation and transpiration are 2 different ways to turn liquid water back into a vapor to join clouds. So they end the same way. You have to explain to me how they are different. And either by looking carefully at the photo or doing this crazy thing called reading, you can figure out how evaporation and transpiration are different. So transpiration is kind of an extra vocab word. It's down here in italics. And also we defined it from our vocab list that I just showed you that might help you. The carbon cycle also has many paths for carbons to be in life in plants and animals, heck, even in viruses, basically all cells, and up in the air as carbon dioxide. And so in the carbon cycle, we need to either look carefully at the picture or read the photosynthesis paragraph to figure out where plants get the carbon that they need. Now, all animals get their carbon from eating plants or eating other animals, so plants do the hard work. There are 3 ways to turn carbon from living things back into carbon dioxide in the air. You do respiration. When you eat your food and break it apart to get energy, you release the extra carbon as carbon dioxide when you breathe out. Decomposition and combustion also release carbon dioxide. You need to tell me how they are different for the second part of 4. The nitrogen cycle is the last cycle that we're going to look at. And in the nitrogen cycle, all living things need nitrogen, but there aren't as many arrows as pathways because there are very few ways to take nitrogen out of the air and split it up into a form that plants can use. So only one kind of living thing does that. So you either need to look carefully at the photo or read carefully. Now, there is a non-living special thing that can split nitrogen in the air, and that's the second part of question 5. When we go on to slide 2, we have a story. So we can open the PDF link and put the story over there, or we can click the blue thing and open the website link. It's the same story. So if I look, what in bird poop helps coral reefs and how does it get to the reef? We have to read carefully for that. So there's an ingredient in bird poop that helps coral reefs. And it doesn't just end up in the reef. The birds aren't just directly pooping in the reef. When we need a time, were rats introduced to islands, the islands that are studied here, and how have they caused problems? So you need to find the bit about rats. Oh, there I see a big paragraph about rats. Question 8. How did isotopes help to prove that bird poop was making it to the coral reef? So isotope is a fancy chemical definition that we have right here. Different forms of an element that vary somewhat in mass and potentially in lifetime and have the same number of protons in their nucleus but different numbers of neutrons. So they are elements or things that look similar chemically and act similar but that we can tell apart. So somehow isotopes helped prove that the bird poop was what was helping the coral reef. And so you want to look for that word isotopes. What are 2 ways that guano, or the bird poop, so fancy name for bird poop, guano, boost the health of reefs? So that's definitely got to be in here. Oh my, in addition to indirect effects. There you go. What other threats do coral reefs face? So besides the rats, there are many other things in the last paragraph that can harm a coral reef. So that's slide 2, the bird poo story. Slide 3 is pretty easy for notes. Again, we can open up the link. And these links are also in Google Classroom. And we can take notes on the steps of natural selection. So step 1, bare rock where nothing lives is exposed. This does come from the book, but we're just going to skip that for a bit. And then step 2, lichens slowly break down the rock in the soil, which can take hundreds or thousands of years. Step 3, when the soil deepens, moss will grow and insects will arrive. And as those things keep living and dying, step 4, they make thicker soil, so ferns, shrubs, and small trees will start to grow. And after hundreds or possibly thousands of years, the soil may be able to support a forest. Not every ecosystem goes completely through succession or ends up with a forest. A forest is not the end goal. So if we went back to the book pages, I could show you where those notes were. The reason I did those notes is because they were much simpler than what the book had. So when the book talks about succession, there would be a lot more to write than what I included. So it's simpler to do it that way. There are 2 types of succession, but before we get into that, in section 2, our first question is about Yellowstone National Park. So 1988, what happened? Check the pictures, and how has the park changed since then? What is an example of a pioneer species? So a pioneer species is kind of an extra vocab word. And if we look carefully, there it is. And where do they grow? Interesting. Secondary succession. So secondary succession is the same as primary succession in the way they end. They end with a complete community of life, but their beginning is different. So read about the beginning here for secondary succession and read about the beginning here for primary succession. They have a different start. Question 14. How are the early stages of succession different from the later stages? So if we read here, it does give you 2 differences between the early and later stages. And then at the end, what is reached at the end of succession? It's not a forest. We need to name something else. So for instance, this is the end of succession. So is this. So succession can end many ways. How do we describe that? And then why don't we always get a forest? Well, it depends on the environment. They give you some specifics that limit where forests can be. That's chapter 19. Only 2 book sections, but an extra story and some notes. As always, talk to me in class or email me if you have questions. Good luck.